Welcome back to my YouTube channel. In this video, I'm going to show you on SPM Form 5, Chapter 5, Trigonometric Functions. Before we start out with to start with this trigonometric function. This function, this here, I'm going to start with the concept of sine cos tangent. The concept of sine cos tangent, where you may regard it as something hard because it is one level at once than what you have learned in Form 3. You get to learn sine cos tangent, but over here it will be the application that's going to be hard. One question in paper 1, while another question in paper 2, compulsory question, part A. Now, to get the concept right, let me give you an analogy. Says you have an eye of Malaysia. Last time we have this. Well, this is the base, and this is the Ferris wheel, I think. Ferris wheel, or the circle. Yeah, the circle, the supporting beam, supporting over the ground. Then you have all the cable, to have a cabin. Each of the cabin go around it. Goes around. You can see the city goes around, okay? Now I know it sounds a little bit weird, maybe it rotates counterclockwise, okay? Goes around and round and round. Now, for the same concept, let's for example, if I were to create a a Cartesian, where system of Cartesian, where over the right hand side here is my x, and here vertically cross at O0, here is my y. What will I find? Says for selected cabin, maybe here, this cabin, what I will find is, if I want to find the angle, we will draw a line to it, to the origin, the height of it. How to get the height of this cabin, say A? Okay, so if you want to get its height, so its height will be here from the origin. This is the height. This is my y height, ya. Right? When this A travels counterclockwise and it reach here, moment later, sometimes later, the concept of height changes. Its height reduces. They have the same radian, but its height reduces over time. The same A, but now the height would be defined from here to here. This is now my ya2, lower, and it's still above the positive. What happened when it goes down to, says, here, then this will be the negative height because it's below the x. This is my y3 for the same A. Okay, so it's all about the height from the base. The same is true in trigonometric, because what I'm going to measure is the angle, where the angle is anything measured from the x-axis. This is my 0 degree. Back to actual definition. back to the normal class. Now in trigonometric function, something called positive angle. With reference to the above figure, positive angle is something span from the x0 counterclockwise. This is a positive angle. Measure counterclockwise from the x-axis, from a positive x-axis, from the positive x-axis. This is what it means a positive angle. Negative angle, because if you have positive, you will expect to have negative angle. So negative angle, that would be measured in clockwise. If you were to rotate over this direction, this will be the negative angle. That will be the clockwise from the positive. It's always measured from the positive x-axis. This is where the 0 located. Okay, now if how do you define sine cos tangent? And also when do you know when it's positive, negative for the respective trigonometric? Says here we have the axis, the x-axis, and the vertical, vertical would be my y-axis. This is positive y. I know you have learned it already. Let's do it again over another perspective. Maybe I can give you some insight. Now if you have a circle, if you want to draw a circle, now I'll try my best to get the round circle, but I know it's not symmetrical. It's supposed to be symmetrical. This is a 0 degree here. If I've had any angle, acute angle, measure positive angle, here to here, theta, any angle within the first quadrant, you always know it's positive, because what happened, if you want to get to know the height, it's height. This is my positive y, always positive y. And this is also a positive length, a positive x. This is my radian. Radian r is always the same in a circle. So no matter how, your sine theta will be opposite over hypotenuse, will be a positive value, positive y over r. The same goes with cos theta. Cos will be the side over hypotenuse. Side is positive x. I include the x positive so that it will give you some idea. Sine cos tangent, tangent theta will be opposite over side. That will be positive value for x. So any acute angle, any angle less than 90, sine cos tangent would be a positive value. This is in degree, so that even if you put into a calculator, make sure you set it into degree, but not radian. All angles shown here are in degree. So 0 here, this is my 0. So y-axis up here is 90 degree. 90, 180 over here, if you go counterclockwise, and 270 would be here, and go round one is 260, one round later. Then what happened is, when it comes to the second quadrant, I'll use same color, so that I'm telling you that is over the same r, radian is the same. Now, although the angle measured from 0, so here to here is any angle more than 90, less than 180, theta 2. What you will normally get is this height. Remember, over left hand side here is height. So its height would be always here. You measure its height. You measure its height. So this is my positive y. However, this length here to here from 0, this is my negative x. Always measure its height. So what happened when I want to look for its sine theta? Sine theta, this is my theta 2, maybe sine theta 2. Sine theta 2, you look at this height, and in this triangle is what you need to focus. You focus at this triangle. Even if the angle is theta 2. Over this smaller angle, sine theta 2 would be this angle. That will be positive y over r. Whereas it's cos theta 2. Now, this is where cos theta, that will be negative x over r. Tangent theta would be equals to positive y over negative x. Over the second quadrant, we only have sine to be positive. The same rules goes even if I want to get into maybe the same, okay, maybe here, this is my r. The angle from here, from 0 up to here. Okay, now this is my theta 3. Theta 3, meaning it's a third quadrant. This angle is more than 180, less than 270. Now if your angle is here to here, the rules always apply, because you always want to look for its height, meaning its height is from here down here. This would be a negative y, but this here to here is my negative x, 2. The rule for this is you always focus at the triangle, the smaller triangle that you can figure out here, here, and here. This is a smaller triangle. So if you were to be in third quadrant, its sine value, sine theta 3, would therefore be sine theta 3 is this smaller angle, So you need to use a Q3 theta 3 minus 180, whereby Q3 is the smaller angle, Okay, Q3, in order to get this smaller angle, maybe Q3 prime is basically Q3 minus 180, so that you get a smaller angle. So therefore, if you get the sine Q3 without the prime, it's actually the same as with sine theta, the negative value, 3 prime, the negative of it. Let me prove how does it goes. Why is it so? Because sine theta 3, if you want to look at this triangle, that would be negative y over r over hypotenuse here. And this answer will be the same as with the negative value of sine Q3. Because it's an acute angle. So you come back to here, first quadrant, but you need to add in a negative sign so that you get y over r. So here, all you need to do is get a negative sign in front. Only the negative sign is different, so you need a negative sign. So sine will be negative. Cos Q3, look at the triangle. Cos will be negative x minus r. X over r is actually cos theta, so you get negative to it. Okay, sine cos tangent will be negative y over negative x, so therefore it's a positive, so that the negative sign will cancel off. This is a place where you will get a positive y over x. So in third quadrant, tangent is positive. The same rules. If it were to be here, when the angle is from here down to here, Q4. This is from 0, 0 to here, Q4. Angle more than 270, less than 360. So what you do is you need to focus again. You focus at same length, but this is a negative y, positive x. Okay, so you need to focus at the smaller triangle. So here and here and here. This is a right angle triangle. So what will it be? In order to get sine Q4, sine is negative y over r. It's also a negative sign, just like the one over here, but with a negative sign. Cos 4 would be cos 4 smaller triangle, positive x over r. Tangent would be negative y over positive x. So if it were to be the fourth quadrant here, then C cos would be positive. Simpler way to remember who is positive, who is negative, that would be add sugar to coffee. Add sugar to coffee. Add meaning all. All is positive. Sugar is sine positive. 2 is tangent positive. Coffee, cos is positive. Okay? So that's the sign of trigonometry. Now, in this chapter also, next week you will learn, maybe you go to some questions and try to solve the problem, but I'll try to get you some exercise after here. Now next, what I'm going to show you would be inversion, the inversion of the sine cos tangent, part 2. In part 1 will be there. Earlier, we learned sine cos tangent, sine of any angle, right? Over there, we have y over r. Here we have a new term called cosecant theta. Cosine, that will be 1 over sine theta, is equivalent. So therefore that will be equals to r over y. You have sine, then you have cos theta. Where cos theta of our acute angle, that will be x over r. We assume theta is an acute angle. How about its inverse? Is secant theta. That will be 1 over cos theta that will be r over x. Some function later that you will learn how to prove, then you need to know this. Then tangent theta, that will be y over x. And cotangent theta is equals to 1 over tangent theta, which is equals to x over y. So now maybe it's easy to memorize. What can you do in order to do that? Sine s sine. Look at the third one is sine cos c. Third one c. So t is t. Okay. So sine cosine, cos second cos. Okay. Now another relationship, how sine cos tangent are related to sine cos tangent. How they are related. Now, for your information, tangent theta is basically equals to the ratio of sine theta over cos theta. You need to know this. You can prove it. Why? Because if you want to have sine theta, what is sine theta? Is y over r dy. Cos theta, x over r. Bring it up, bring it down. The x cancel off each other. Then you will get y over x, which is tangent theta. Okay? It doesn't need to know the proof, but tangent is sine cos. Sine by cos is tangent theta. Okay? Now, next, there are some facts also you need to know before we can start to do some questions. You need to link them accordingly. Just now is all about positive angle. Now what happened when you have negative angle? Well, okay, this is my x. When it goes down here, maybe an angle goes down, negative theta. Okay, so with this case, for this kind of case, negative angle, sine of this negative angle, that will be equals to negative of the sine. Okay, because it's now going down already. The acute is now. The cos of this acute angle will be equals to negative. Oh, sorry. Add sugar to coffee. So this is a positive. As long as it's within the acute angle, add sugar to coffee. So please don't confuse, because add sugar to coffee is positive. Whereas tangent of this acute angle, that would be negative tangent theta. This is for your information. So the rule would be quite clear by now, I hope. So that you are able to relate them when question comes in. You have a negative sign. First of all, you have to have this diagram. Identify, add sugar to coffee. Then where is the angle located? It helps you to know whether you need to add in a sign, a negative sign to it. Another condition, right angle triangle. If I know this is angle theta, this is my radian r, this is my positive y, this is a positive x. If this were to be by angle theta, you will need to agree with me. Maybe you take some time. The angle here would be 90 minus theta, right? It's true. This is 90 already, so this is theta, 90 minus theta. Some questions without using expansion, simple way to cos. To find out what's the cos for this angle, 90 minus theta. You may expand it, but sometimes you doesn't, because cos of this angle is x over r, where x over r is basically equals to sine of the opposite, theta. Okay, cos is sine of here. Sine So sine would be here to here is basically cos of the angle. All this angle is an acute angle, whereas tangent of this 90 minus theta of this angle will be equals to cotangent theta. It's always true. You may want to prove this when you have time. Let me give you an example. As following. For example 1. If you have an angle of 420 degrees. You're like, what? More than 360. How can you do that? First of all, you need to. It's compulsory. You need to identify where is the location of this 420. If it's less than 360, it's easy. But more than that, how do you do? Now this one here is always hypothesis x over right hand side. In order to get 420, you need to go one round, 360, and then go another 60, isn't it? So that here, 360 plus 60, 360 plus 60, that will be 420. So you know that this angle falls in the first quadrant. It's a equivalent acute angle. So that will be easy. That will be so much easy. So first step is you find out where's location of this angle. So sine 420 will be equals to sine 60. Then you use calculator and find out what's it. Cos 420 will be equals to a cos 60. Tangent 420 will be equals to tangent 60. 60 is one of those standard angle. It's easy to find out. I'm going to show you how later in the next slide. 4-point angle. Remember, locate its direction. Locate where it belongs to. Now B, maybe negative 150 degree. So first of all, identify where is it located. So again, negative, so it goes clockwise. 150, that will be more than 90, is less than 180, maybe here. This is negative 150. So in order to get sine cos tangent, you need to look for the lower triangle, which is here. It's 150 here. I would say this is 30 degree, so that I form this triangle. Then if you want to find out what is sine negative 150, that would be add sugar to coffee. It helps me. I would say it will be a negative sine 30 equivalent. Why is it negative? Because it's over the third quadrant, tangent positive. For cos of this angle, that would be negative, yes, cos 30. Tangent negative 150. What would it be? That would be positive because it's in the positive t, positive tangent 30 degree. Okay, you may use a calculator to figure out what's the value. Okay, now next, we are not going into anything too hard yet. Third one, before I teach you on the standard angle, very famous question. The given tangent theta is equals to q. and you know that this angle, you need to know the range. Okay, so you know it is an accurate angle. First of all, they ask to find out what is cotangent theta. So cotangent theta would therefore be equals to 1 over tangent theta. That would be 1 over q. It's easy. First one. Second one, that would be a little bit hard because now they ask for what's the cos 90 degree minus theta. So that would be a little bit hard to do without a diagram. So I would advise you is advised to draw a diagram. I'm a right hand person, so my right hand angle will be look like this. And then what is given? Tangent theta is q. So if this were to be theta, this is where 90 minus theta is located. If it is the angle here is theta, tangent theta is q here, 1 here. Since it's a Pythagoras theorem, this is a right hand triangle, so the hypotenuse will be the square of 1 plus q squared. So that I will be able to find out what is my cos 90 minus theta, which is here. Cos will be q over here. That will be q over square root of 1 plus q squared. Okay? It's important to have a diagram. It helps you to solve quite lots of questions. Okay? This is a technique that you learn. I hope you will learn from here. Because the following, you may pause this video, but since I am progress, I'll try to make it 45 minutes per video. You may pause it to have a look at this. Okay. Next concept is so standard angle for Pythagoras theorem. Before the second part would be the part 2 of my video would be on the graph sketching. Standard angle. For standard angle, there's analogy to have a triangle. Equilateral triangle. It says 2 here, 2 here, and I draw a perpendicular line to it, bisecting line. Then the length here would be 1 and 1. Since this is initially this is an equilateral triangle, the angle here would be 60, 60, and the angle here and here should be the same, which is 30 degree. Okay, and since this is a right angle triangle, so the length here would be square root of 3. 2 squared minus 1 square root equal to 3. So it's so much simple now that in order for you to find out what's the angle for 30 degree, and also 45. We have another triangle, I've forgotten, equal length. If you have 1 and 1, 90 degree, so here would be square root of 2. So that you will get the angle here and here to be the same, which is 45. So in order to find out the standard angle of theta, 30, 45, and 60, for the value of sine, cos, tangent, get a table. So sine 30, that will be 1 over 2. You may fill up this form, this table accordingly. Sine 45, that would be 1 over root 2. based on the triangle. Okay, sine 60 would be square root over 2. Square root 3 over 2. The same goes with cos. This is 3 over 2. This is 1 over root 2. This is half. Tangent, that will be 1 over root 3. This is 1. This is root 3. And you would realize sine tangent and cos 60, sine 30 is equivalent to cos 60. Cross. You should have this in mind. It helps you to solve quite lots of questions. If you know this, it will be an advantage, because sine 30 is basically equals to cos 90 minus 30. So if it were to be cos 90 minus theta, that would be sine theta. This is how you work it out. They are complementary. They complement each other. Well, I think I will leave it to you. Part 1 of my video. There are 2 parts. Part 1 will be the theory. I think in my part 2 of my video for trigonometric function, I will involve graph sketching, the identities proving, and also some exercise to help you excel this course. But no matter how, you may start on with your practice exercise. 20 questions. It relates to what you have discussed. If you really can't do it, maybe you want to watch my part 2 of my video. That's all for me. That's all for now. Stay tuned to my next video. I thank you. Bye bye.